Hi everybody. Since we didn't get a chance to go over the projectile motion tests before you'll take your final exam, I thought I'd post a key of me going through the answers. Hopefully you can have some time to sit down and watch this and go through it question by question. I know you don't get to see your answers, and I'm sorry. I have the tests home with me, but I really can't bring them into school right now. So you can just follow along and hopefully get your questions answered. Number 1. A tank fires a shell at 30 degrees above horizontal. The same tank then drives forward and fires another shell at 30 degrees above horizontal. As it drives, use this information to answer the next couple of questions. So which one has the greatest range? So the first tank has a shot that has a certain velocity in the x direction and a certain velocity in the y direction. Initial velocity in the y direction. They shoot at the same velocity, both at 30 degrees. But the second one has some additional velocity before it's shot. And that would be how fast the tank was driving forward. So the first shell just has Vx, whereas the second shell has Vx plus this driving speed of the tank that you'd have to add in the x direction. So that's going to give it a longer range. They have the same exact amount of time in the air because they're shooting from the same height, landing in the same spot. They have the same VIY, same delta y, same everything in the y direction. So their times are the same, but the second one's going to have a bigger range because it has that bigger x component. Number 3, theoretically, if an arrow shot at an angle of 25 degrees above horizontal and delta y is 0, so it lands on the same height, launching the arrow at the same speed, but at 65 degrees, the complement would give the same range, but be in the air longer because it has a bigger y component. Number 4, Jose can jump vertically 1 meter from his skateboard when it is at rest. When the skateboard is moving horizontally, Jose can jump no higher. The x and y components are independent, so whether the skateboard is going left or right has no bearing on whether he can jump vertically. Number 5, which of the following is an example of projectile motion? So this is where there's no wings, no thrust. The thing is just in the air. That would be a thrown baseball. Path of a projectile with no air resistance is a parabola. A piece of chalk is dropped by a teacher walking forward at a speed of 1.5 meters per second. From a stationary student's perspective, so somebody just watching this happen, chalk's going to fall in a parabola going forward, so it falls down and forward because the teacher was walking forward. Number 8, at the instant a ball is thrown horizontally with a large force, an identical ball is dropped from the same height. Which one hits the ground first? They hit the ground at the same time because they have the same delta y, VIY, and acceleration y. Alright, number 9. A projectile is launched horizontally and it hits the ground in 0.8 seconds. If it had been launched with a much higher speed in the same direction but from a lower height, it would have hit the ground in less than 0.8 seconds. The height, the delta y, is very important for horizontal projectiles. It dictates how long this thing's in the air, so the lower it is, the less time it's in the air. Number 10, after a rock that is thrown straight up reaches the top of its path, it starts to fall back down. Its acceleration is the same as at the top of the path. Its acceleration is always negative 9.8. Number 11, we're using the picture. At what point in the ball's path is the vertical component nearly 0? So up and down is nearly 0 at point B. In the figure above, the ball's speed, and by magnitude we just need like a speed. We don't want a direction or anything like that. Remember, vectors have a direction and a magnitude. We just want the magnitude, just the number. The ball's speed is least at B as well, because that's when its x component is nearly 0, so it just has a y component. I'm sorry, its y component is nearly 0. It only has an x component up there at the highest point. 13, the ball's speed is greatest at D. It's had the most time to speed up on the way down. Oops. And 14, the horizontal component of the velocity at A is going to be equal to the horizontal component of its initial velocity because the horizontal component of the velocity never changes. Last one for this section. At what point is the ball's speed about the same as when it was tossed? That's when it's about level to when it was tossed, and that's point C. 16, a projectile is moving upward and rightward towards the peak of its trajectory. So it's doing one of these, and it's about right here. Which of the following force diagrams represents the force or forces acting on the projectile during this portion of the flight? You only have gravity pulling it down. That's kind of a definition of a projectile. So that'd be A. 17. Cannonballs with different masses are shot from cannons at various angles above horizontal. They all leave from the ground and land at the ground. Velocities are given. Notice they have the same vertical component. All of them have a vertical component of 20. That's huge. We're told to rank the time the cannonballs are in the air from shortest to longest, but they all have the same VIY, same acceleration in the y direction, and the same delta y. Therefore, they are all going to have the same amount of time in the air. 18. In the absence of air friction, the vertical component of velocity doesn't change. That's false. It's the x component, the horizontal component, that doesn't change. 19. The ball is thrown into the air at some angle that's not 90 or 0. At the very top, its velocity is entirely horizontal. Number 20. A rock is thrown with a velocity of 20 meters per second at an angle of 33 degrees above horizontal. It returns to ground level. What combination of changes would have to produce a larger range? So 33 degrees, its complement is 57, so that would give the same range, but by throwing it faster at that complementary angle, it has to go further. If you threw it the same speed at the complementary angle, it would go the same range. But by throwing it faster, that means your x and y components have to get bigger, and it has to go further. You'd have a bigger x and a bigger y components if that hypotenuse got bigger. If you make the launch angle decrease, remember 45 degrees is your maximum range. So if you go away from 45 degrees, that doesn't have to work. And if you increase the launch angle but slow it down, that doesn't have to produce a larger range, because what if that velocity you shoot it out at is 1 meter per second? It's definitely not going to go further. 21. A ball in the air will never go as far as physics ideally would predict, because, and this is where you're talking about factors that we've pretty much eliminated in our labs. We always say we assume there's no air friction. If you read back, there's tons of questions in this test where it says assuming no air resistance, neglect air resistance. That's because air friction really does factor into real life situations. We just try and minimize them by using really streamlined, like ball bearings, but in reality air friction does slow things down. Number 22, cannonballs launched from ground at an angle 30 degrees above horizontal at 30 meters per second. Ideally, the ball will land on the ground with a speed of, and if it goes from the ground and it lands on the ground, it's going to land at the same speed. 23, an object is dropped and falls freely to the ground with an acceleration of negative 9.8. If it's thrown upward at an angle instead, its acceleration would still be negative 9.8. It doesn't matter whether something is thrown, dropped, whatever. If it's in the air, its acceleration is negative 9.8 meters per second squared. 24, a cannonball is launched horizontally from a tower. That's the key part. So cannonball is launched horizontally from this tower. If the cannonball had a barrel velocity of 60, where will the cannonball be 1 second later? So 1 second later, it's going to be, if you use your Vx times t to get your range, Vx is 60 times 1, it's going to be 60 meters down range. Finally, a projectile is launched at an angle from the top of a tower. Just before the projectile lands, its speed is going to be, it's going to be faster than its launch speed, because when it was level with the top of the tower, its velocity was the same as when it was launched. But now it's had extra time to land below its launch height, so it's going to gain more speed there, so it's going to be greater than launch speed. Now I've pretty much run out of room on this video segment, so I'm going to have to make a second video for the short answer, so be on the lookout for that. Thanks.